So now I'm going to go over this step by step as to how I did it. Step 1. We wanted to count the elements. We counted them, right? 3, 8, 2. 1, 2, 3. We noticed that nothing was balanced. Now, when you're counting these elements, you want to make sure that you want to make sure you remember each capital letter represents a new element. So that's how I knew that this was carbon and oxygen, not cobalt. Cobalt would look like this. Capital C, lowercase o. Right now this is one element. But because it's a capital O, that's how I know it's two different elements, carbon and oxygen. The subscript will tell you how many there are of that element, and something you want to know is that you never change the subscript, and when you start these, you typically want to draw a dotted line down here through the arrow to separate your left side from your right side. It just helps keep track. Now, step 2, you want to find which one was unbalanced. What you want to do is add more to the side that has less. Whenever you find something that's not balanced, you add more to the side that has less. You don't just add more carbons though. The way you increase the number of carbons on the smaller side is by changing the coefficients. You don't add the coefficients. You only change the coefficients. Now, step 3, we recounted each time. When I changed this to a 3, yes, I recounted my carbons, but I also had to recount my oxygens. Right? When I changed this to a 5, I only had to recount oxygen because that's the only thing there. When I changed this to a 4, I had to recount hydrogen and oxygen as well. And step 4 is that you have to repeat steps 2 and 3 sometimes over and over and over again. Sometimes these take several steps, several repetitions. But something to keep in mind is sometimes you need to change the coefficients more than once. Sometimes you have to change this to a 3, and then that screws up how many carbons are on this side. So then you have to change this, then you have to change this, then you have to change this. And you go back and forth until you finally get it balanced. Sometimes what people do is they overbalance it, right? They put, instead of 1, 5, 4, 3 here, they put a 6 here. And what that would do is that they would have to put a 2 here, and then a 10 here, and then an 8 here, right? That's still balanced. If you can eventually balance, it doesn't matter how big your numbers are. If you can eventually balance it out, you're fine. Because the last step, that's when you reduce it. Let's say instead of 1, 5, 4, 2, let's delete all this other stuff. So what was it? It was 1, 5, 4, 3. Right? This is not reducible, but let's say I doubled these numbers instead. Right? Instead of having it 1, 5, 4, 3, I had it balanced as 2, 10, 8, and 6. But let's say this did balance. Well, are all these numbers able to be reduced? Yes, I can divide all of them by 2. If you divided each of those numbers by 2, you would end up with 1, 5, 4, 3. So it doesn't matter that I overbalanced it because I was able to reduce it back down to the right answer. And that's really what this note says down here. You don't really have to read it. But I will do another practice problem with you guys. So let's do this one. Iron combines with chlorine gas to produce iron chloride. Iron 2 chloride? Iron 6 chloride? No, iron 3 chloride. That's what it is. Iron 3 chloride is the way you would say it. But that's irrelevant. So we draw a dotted line, right? We can separate our reactants from our products. And we write out what we have. We have iron, Fe, and we have chlorine, which is Cl. On the right side, we have iron, which is Fe, and we have chlorine, which is Cl. How many irons do we have on the left? Well, we have 1 times 1. That's just 1 iron. How many chlorines? We have 1 times 2. That's 2 chlorines. How many irons do we have on the right? We have 1 times 1. That's 1 iron. How many chlorines? We have 1 times 3. That's 3 chlorines. Iron's balanced, chlorine is not. So let's go ahead and balance it. This is the smaller number, so let's increase it. I'm not going to be able to balance it because if I change this coefficient to a 2 by 1 step, now I have 2 times 2. Now I have 4 chlorines, right? And that doesn't balance out. So let's go back over here and increase this number because this is a smaller side now. Let's change the coefficient from a 1 to a 2, right? I'll change it by one step. So now I have 2 times 1, I have 2 irons, and I have 2 times 3, now I have 6 chlorines. So let's go back over here and try to fix chlorine again, right? I'm going to change this coefficient from a 2 up one step to a 3. Now I have 3 times 2, now I have 6 total chlorines. Now chlorine is balanced. That coefficient didn't change any other molecule, so I'm good. Now I want to try and balance iron. I have 2 irons on the right side. If I change this coefficient from a 1 to a 2, now I have 2 times 1, which is 2 irons. And if you look, I have 2 and 6. Everything's balanced. So let's move on to the next example. The next example, we have I don't have enough colors for all this. Yeah, I do. I have sodium. I have oxygen. I have hydrogen. I have calcium. And I have bromine. Now I'm doing this one the way that the other way, other than writing it every element out a bunch of times. You could actually write everything below the reaction instead of below the arrow, right? And that way you don't have to write the elements twice. I prefer this method. It's less writing. So now I want to keep count. I have 1 times 1. That means I have 1 sodium. I have 1 times 1, 1 oxygen. I have 1 times 1, which is also 1 hydrogen. Now I have 1 times 1, which is 1 calcium. And I have 1 times 2, which is 2 bromines. And if you look on the right-hand side, I have 1 times 1. I have 1 calcium. I have 1 times 1 times 2, because it's inside parentheses, 2 oxygens. I have 1 times 1 times 2, because it's in parentheses, 2 hydrogens. I have 1 times 1, that's 1 sodium, and I have 1 times 1, that is 1 bromine. Now I counted all my elements, and my sodiums are balanced, and my calciums are balanced. What's not balanced is my bromine, my oxygen, and my hydrogen. A trick is to always save oxygen and hydrogen for last. It typically works out. It doesn't always work out that way. Sometimes you have to balance it first. Let's try the way that works most of the time. The higher percentage play is bromine. So let's change our bromine. Instead of we have less bromines on the right hand side, so I'm going to change this coefficient from a 1 to a 2. What that does is it gives me 2 times 1. Now I have 2 sodiums. And then I have 2 times 1. Now I have 2 bromines. And bromine is balanced, but sodium is not. So let's fix sodium now. There's less sodiums on the left-hand side, so I'm going to change this coefficient to give myself more sodiums from a 1 to a 2. I have 2 times 1. I have 2 sodiums, and sodium is balanced. But that also changed my oxygen. So I have 2 times 1. I have 2 oxygens. And I have 2 times 1. That's 2 hydrogens. And looky-hoo. Everything's balanced. I have 2, 2, 2, 1, 2. 2, 2, 2, 1, 2. And the last step would be to reduce this. Can I divide all these numbers by a common denominator or by a common factor? And no, you cannot. You can't divide everything. The only thing that you could divide it all by is 2, but the 1 doesn't divide evenly, so you can't reduce it. It's already reduced. That's your final answer. And that is how you will be doing these problems. Let me say bye to you guys. Bye guys. Have a great day.